Hey everyone, you're using one right this second, but I bet you've never really thought about it. Today, we're going to pull back the curtain on one of the most important and maybe most overlooked pieces of tech that makes your internet work, the network gateway.
Okay, so picture this. You're chilling at home on your Wi-Fi, you go to load up a website, right? Your home network, it's its own little world. And the internet? That's a totally different universe. They don't even speak the same language. So how on earth does that happen? How do they connect?
Well, it's all thanks to an unsung hero of the internet, the network gateway. This is the device that makes all the magic happen.
All right, let's dive in. First things first, what is a gateway? Really, let's break it down.
Okay, so here's the official definition. A network gateway is basically a bridge. It connects two totally different networks that, on their own, couldn't talk to each other because they use different rules or protocols. Think of it as the bridge between your private home network, that's your LAN, and the huge public internet, which is a WAN. Without that gateway, your home network would be totally cut off. An island.
Okay, I know what you're thinking. Wait a minute, isn't that just a router? And that is an excellent question. It's probably the most common point of confusion, and for a really good reason that we're going to get to in a sec. But the short answer is nope, they're not the same thing at all.
So let's really nail this down. A router? Think of it like a mail sorter in a single country. It knows all the local addresses and gets the mail where it needs to go, but it's all using the same postal system, the same language. It just routes traffic. A gateway, though, is more like an international customs agent and translator. It takes a package from one country, inspects it, maybe even repackages it, and translates the address so it can be delivered in a completely different country with a different system. See the difference? A router just forwards stuff. A gateway actually translates between different kinds of networks. That is the absolute key takeaway here.
And this is why everyone gets them mixed up. That little box blinking in the corner of your room that your internet company gave you, we all call it a router, but it's really a gateway in disguise. It's actually a modem, a router, and a gateway all crammed into one convenient package. It's doing all three jobs, acting as the one and only door to the internet for your entire home.
Okay, so we know what it is. Now let's talk about what it does. A gateway wears a lot of hats. It's way more than just a simple doorway. Job number one, and this is its main gig. It's a translator, a protocol converter. Let's say your home network speaks TCP/IP, which is kind of like the internet's main language. But you've got a smart home device that only speaks a different language, like MQTT. Well, they can't talk directly. The gateway steps in, listens to one, translates the message, and speaks it to the other. Boom, communication.
All right, its second job is being a receptionist. This is a really cool trick called Network Address Translation, or NAT. So inside your house, your phone, your laptop, your smart TV, they all have their own private local address. But when they go out to the internet, the gateway makes them all share a single public address. It's like an office where everyone shares one main phone number. This does two amazing things. One, it keeps your private devices hidden and secure from the outside world. And two, it saves a ton of public IP addresses, which are a limited resource. Super important.
And job number three, it's your security guard. Or maybe a better word is bouncer. It stands at the door of your network and checks the ID of every single piece of data trying to get in or out. It's got a list, the firewall rules, and if something looks sketchy or isn't on the list, it gets blocked. No entry. This is your first line of defense against all the nasty stuff on the internet.
So, let's put it all together. What does a packet's journey actually look like? Well, it happens in the blink of an eye, but it's a pretty intense process. First, a data packet from your computer hits the gateway. The gateway immediately checks it out. Where are you going? What language are you speaking? Then, it translates the packet into a language the internet understands. Next, it figures out the fastest way to send it. Then it does a quick security pat down to make sure it's safe. And finally, whoosh, it sends the converted, secure packet on its way. And this happens for literally everything you do online.
Okay, but these things aren't just in our homes, right? Not at all. Gateways are everywhere, and they come in all sorts of specialized flavors. Let's check out some gateways in the wild.
And this is what I mean by specialized. You've got your standard internet gateway, sure, but then you have cloud gateways that bridge a company's private data center to a public cloud like AWS or Azure. You've got IoT gateways that collect data from thousands of tiny sensors in a smart factory. You even have voice gateways that take your analog phone call and turn it into digital packets to send over the internet. Every single one is a gateway, but they're all tailored for a very specific mission.
Let's zoom in on a real-world example from the cloud world using AWS. They have two common types of gateways. First, the Internet gateway. Just think of this as a big, two-way superhighway. Data can flow in, data can flow out. Simple. But then, you have the NAT gateway. This is totally different. It's a one-way street. It lets your private, secure servers go out to the Internet to grab, say, a software update, but it slams the door shut on any connection trying to come in. It's a critical security tool. See? Two gateways, two very distinct jobs, solving different problems.
All right, so why does any of this matter? What's the big takeaway? To put it bluntly, without gateways, the Internet just wouldn't exist as we know it, period.
They are the glue that holds everything together. They provide that critical interoperability, so all our zillions of different devices and networks can actually communicate. They're that essential security checkpoint protecting us. They make it possible for networks to grow and add new things without having to rebuild everything from scratch. And they keep things running smoothly. Really, they're what stops the Internet from just being a bunch of isolated, disconnected islands of data.
When you boil it all down, this is their superpower. They take the absolute chaos of countless different protocols and networks, and they transform it into the single, functional, connected world that we just take for granted every single day.
And this all leads to a really cool forward-looking question. With things like AI and edge computing getting bigger, gateways are having to do more than just translate and route. They're starting to make intelligent decisions right at the edge of the network. So the question is, are we seeing the humble gateway evolve from just being a door into being the actual brain of the network? It's a pretty wild thought. Anyway, thanks for diving into this with me.